Good evening, students. Today we are going to discuss an important topic in grade 11 chemistry, that is chemical equilibrium. In previous lectures we have discussed what is chemical equilibrium and examples, and in this lecture we are going to discuss about law of chemical equilibrium and equilibrium constant. Before we enter into this, let me give an equation. A plus B, that is forward reaction will give you C plus D, and this C plus D again gives A plus B, that means backward reaction. So in such condition we can easily mention that the rate of forward reaction is equal to the rate of backward reaction. So this is a reversible reaction wherein the rate of forward reaction is equal to the rate of backward reaction. Now how to write the law of chemical equilibrium? It says that if you talk about forward reaction, the rate of forward reaction is directly proportional to the product of concentration of reactants. Now you know that if you mention square bracket, it indicates the concentration. So we can write like this: rate of forward reaction is directly proportional to the product of reactants. The product of reactants. Now if you want to remove the proportionality symbol, we will write a constant K. So let us write like this: rate of forward reaction is equal to K1 into concentration of A into concentration of B. So this is our equation 1. Now if you consider the rate of backward reaction, it is again directly proportional to the concentration of the products. That means if you multiply concentration of C into concentration of D, you can say that the rate of backward reaction is directly proportional to this. Now to remove the proportionality symbol, again we can write like this: rate of backward reaction is equal to K2 into concentration of C into concentration of D. This is our second equation. Now where K2 is equilibrium constant for backward reaction, K1 is equilibrium constant for forward reaction. Now we know this very important thing, that is rate of forward reaction is equal to rate of backward reaction. So let us equate these two. If you equate, what we get? K1 into concentration of A into concentration of B is equal to K2 into concentration of C into concentration of D. Now let us do one thing, take K2 to the other side, we get K1 by K2. Now the concentration of C into D by concentration of A into B. Now we know that at a given temperature, this is a constant and this is also a constant. So the ratio of two constants can be a constant. Let us take it as K, which is equal to C into D by A into B concentrations. Now this is equilibrium constant K. So for this reaction, A plus B gives C plus D, that is a reversible reaction, we get equilibrium constant is equal to, we can write like this: the product of concentration of products. See, the product is nothing but multiplication here, C into D, that is concentration of products, by the product of concentration of reactants. So using this we can get the formula for equilibrium constant, a very important thing. Now let us see if there are some coefficients for this, what will be your equation. So up to this you have understood. Now if you take coefficient A, small b, small c and small d. So this is the equation. For this, how do you get the equilibrium constant? We can write K is equal to, now C to the power of coefficient, D to the power of coefficient divided by concentration of A to the power of, this one is known as coefficient here, into B to the power of coefficient. If you have coefficient, you will get equilibrium constant relation like this. If you take an example, Haber's process, N2 gas plus 3H2 will form 2NH3 gas. So this is an important equation in Haber's process. You know this, formation of ammonia. Now for this we have two things. First one Kc, second one is Kp. Now what is meant by Kc? K is equilibrium constant and C is concentration. In terms of concentration you will write the equilibrium constant, and the P is partial pressure. If you are having the gases, you will write the equilibrium constant in the Kp value. So let us write both for this. First one, how do you write Kc? Nothing but NH3 is the product, concentration in square bracket. What is the coefficient here? 2. Therefore to the power of 2. Hope you are able to understand. According to this relation, we are taking an example and writing the value of Kc. Now second one. Here you have N2. So only 1. So therefore no need to write to the power of 1. Into the concentration of H2. Here coefficient is 3. Therefore to the power of 3. So this is your equilibrium constant in terms of concentration C. Now if you want to write the units for this, let us write the units. See, the units will vary depending upon your coefficient. Your units will vary. Now what I will write? First one, mole per liter square, because the unit of concentration is mole per liter. I have written here, you have square, hence I have written square, divided by N2. Concentration is again mole per liter, and here concentration to the power of 3, we can write it as mole per liter whole cube. Now here you are having 2, here you are having 4, so hence we can cancel this and write it as 1 by mole to the power of liter square. Fine. So if you want to take it to the numerator, therefore units of Kc for Haber's process we can write like this, mole to the power of -2 into L square. So this will be your method of writing the unit. So hope you have understood this. Now let me write the value of Kp for this. Now we need to write the value of Kp. So Kp is equal to, instead of concentration we will write P, that is nothing but partial pressure of NH3. Here coefficient is 2, therefore write it as P square, divided by, now again partial pressure of N2, nothing, you can take it as 1 coefficient, therefore here P to the power of 1, no need to write. Next, here the coefficient is 3, therefore partial pressure of H2, and this can be written as Q. So this is your equilibrium constant for writing gases. So Kp, equilibrium constant in terms of partial pressure, is equal to P square NH3 by Pn2 into P cube H2. Now for this, how to write units? Units for Kp. See here, partial pressure is represented in atmosphere, hence we can write it as atmosphere square, divided by, here you are having atmosphere into, so to the power of 3, so atmosphere cube. Now once again you can cancel this and write it as 1 by atmosphere square, nothing but atmosphere to the power of -2. So this is the method of writing Kp as well as its units. Now here we can understand one important thing. What you can see is the coefficients of reactants. Here if you add, nothing but 4, and here the coefficient of product is 2, so this is not equal. If coefficient of reactants is not equal to coefficient of product, then you will get some units here, otherwise you won't get any unit. Let us take an example for this. Now here we have taken an equation where the coefficients of reactants, if you add, 1 plus 1 is 2. So here we can say that the coefficient of reactants is 2. Here what is the coefficient of product? That is also 2. So coefficient of reactance is equal to coefficient of product. Now how do you write Kc? Kc is equal to concentration of product, that is Hi square, because of coefficient 2 I wrote to the power 2 divided by concentration of H2 into concentration of I2. Now what will be your unit here? This is nothing but mole per liter square divided by, for this we know, mole per liter into mole per liter. So everything gets cancelled out and we can say that there is no unit for this. So very important thing, if you know that concentration of reactant, that is the sum of the coefficients of the reactants, is equal to the coefficient of product, then you can say there is no unit for this. How to write Kp? For this gas you can say P square Hi divided by PH2 into PI2, where P stands for partial pressure. Now what will be your unit? You know, atmosphere square by atmosphere into atmosphere, that is ATM. Everything gets cancelled out, hence we can say here also there is no unit. Now we understood an important concept. What is that? If coefficients of the reactants is not equal to the coefficients of the product, then you will get some unit for Kc and Kp. Otherwise there will not be any unit. Now let us solve the numericals. Now if you see, they have given 7.12 in the review exercise. Find out the expression for equilibrium constant for these two reactions. Now first one, if you see, what will be your Kc? Here you know NO2, concentration of the product, that is NO2 to the power of coefficient divided by concentration of NO to the power 2 and then O2 to the power 1. So this will be your expression for Kc. Very simple. Now if you write what is Kp, because they are in the gaseous state, we can write the equilibrium constant in terms of partial pressure, nothing but P square NO2 by, here you get P square NO into PO2. So this is your expression for Kp. They are asking only the expression, we are not taking any unit here. Now if you take, this is solution for A we have written. Now if you write the solution for B, very simple. Here you are having solid, and you know the concentration of solid is expressed in 1. So we can take it as Kc is equal to, what is the product here? We have calcium oxide and CO2. First of all, let us write like this. CaO, this is solid, and concentration of CO2, this is gas fine, divided by, here again you got the solid, concentration of solid. So this is taken as 1. So therefore we can write it as concentration of CO2 will be your expression. So very simple, case is nothing but concentration of CO2, because this is 1 and this is also 1. Now what will be the Kp value? Kp also you can take the same way. Solid we don't consider, hence we can simply write it as the partial pressure of CO2. So this is the expression for equilibrium constant in terms of partial pressure. Hope we have understood this. Now let us move to 7.13. Now in this, the last question, in the concept of chemical equilibrium and equilibrium constant, they have asked to find out the units for, that is, these two equations in terms of both concentration as well as partial pressure. So let us solve this. First one, first write Kc. So Kc is equal to, you know that, the product of concentration of the products, nothing but concentration of PCl3 into Cl2 by concentration of PCl5. Now in this condition, you know the unit is mole per liter, and here also the unit is mole per liter. The coefficient is 1, hence you write only 1 here. Now here this is mole per liter, so you can cancel this, and what will be the final unit for this equation? It is mole per liter. So we got Kc as well as we got the unit. Now if you write down Kp for this, Now here you have two products, partial pressure of PCl3 into partial pressure of Cl2 divided by the reactant partial pressure, that is PCl5. If you come to the unit here, atmosphere into atmosphere divided by 1, nothing but atmosphere. Cancel this, therefore the unit for this particular equation is atmosphere. See, again you know this, we have the concentration of reactants, that is coefficients, is 1, and here the sum of the coefficients is 2, which is not equal, hence you got some unit. Now try to solve the second one. Less than 1 minute you try to solve this. The second one, again you know, product SO3, the concentration in square bracket and coefficient is 2, therefore to the power of 2, and divided by concentration of SO2, coefficient is 2, therefore to the power 2, the concentration of O2, coefficient is 1, hence leave like that. So this is the expression for Kc. What about unit? Mole per liter, here square, divided by, here also you have mole per liter square, and last one is only mole per liter. Hope you have understood this. I have just substituted the unit for each concentration. So this gets cancelled out and you get 1 by mole per liter. If you write in the numerator, it is mole inverse and liter. Hope you have understood this. Same way Kp. You can write the Kp in similar way, P square SO3 by, here you got P square SO2 into P of O2. So very simple, you know the concept, hence you have written the expression for this. What will be the unit for each concentration, that is in terms of partial pressure, it is atmosphere. So atmosphere square by atmosphere square into atmosphere. This gets cancelled out, and 1 by atm we can write it as atm to the power of -1. Hope you have understood this. First one expression in terms of concentration, second one expression in terms of partial pressure. In both the cases we have written the unit. So in this lecture we have completed law of chemical equilibrium and equilibrium constant, and we will move to the next term in the next lecture. Thank you so much.